Let us now focus our attention on quadratic polynomial. Quadratic polynomial. So in this lecture we will focus on basically on graph of quadratic polynomial and some other aspects. So let me start by taking a general quadratic polynomial like ax square plus bx plus c. When I say it is a quadratic polynomial, then I am saying that a is non-zero, right? The leading coefficient or the coefficient of x square term is non-zero, right? To understand this quadratic polynomial, I will do some basic manipulations to convert it into a form where there is a complete square term. Complete square. It is also known as completing the square method of solving quadratic polynomials. So when I want to make it into a complete square, I'll perform some of the steps like this. The first step that I'm going to perform is making the coefficient of x square, making coefficient of x square equal to 1. This is a pretty simple thing to do because I can rewrite it as a common x square plus b by ax plus c, right? So this is very simple. I just took the leading coefficient common, or I took it outside the bracket, and there is c by a. Okay, all right. The second step that I am going to perform here is I will add and subtract the square of half of coefficient of x. So I'll add and subtract the square of half of coefficient of x. What is the coefficient of x? It is b by a. So what is half of coefficient of x? B by 2a. And what is the square of half of coefficient of x? B by 2a squared. Alright. Okay. So now I will rewrite it as x square plus b by ax. Then I will add the square of half of coefficient of x and subtract the same thing. Now this expression and this expression are the same expressions because I have not changed anything. I have added something and I have subtracted the equal amount. So the expression is still intact. Alright, this is just a manipulation. To do what? To make it a complete square. How? Now if you look at this, what is this? A square plus b square plus 2ab. Let me show you. A into x square plus, how can I write this term? Twice of b by 2a into x, and then there is b by 2a whole square. Now look at this expression. A square plus b square plus 2ab, and then the rest of the expression b square by 4a square plus c by a. Okay. Okay. Now the first part has already become a complete square. So let me write it as x plus b by 2a whole square. Right? And the rest of the portion can be written as, if I take the LCM, let us take LCM as 4a square. Okay, let the LCM be 4a square. Then this will be nothing but b square, and this will be minus 4ac. Okay, now I can enclose it in a bracket because when I open it, this negative into minus b square by 4a square will give me my first term, and minus of minus 4ac by 4a square will give me my second term here, that is c by a. Okay, so I have still not changed anything. I have just rewritten the expression. Let me erase these two. Okay, now look at this expression. Now look at this expression. The only variable is x, right? So we cannot do anything about this term, right? The variable is this x here. and on the left hand side I had f of x. So this is the rephrased form or rewritten form of ax square plus bx plus c, right? I've done some manipulations and written this as this term. Why have I written it in this form? Because now I'll be able to do some deductions. The first thing that I want to highlight here is that this term b square minus 4ac has got a special name. B square minus 4ac, we write it as capital D and call it discriminant. Discriminant. Okay, we call it discriminant. And if you still rewrite it as x plus b by 2a, you need to pay your rapt attention here, because I am going to make some deductions that will make a lot of questions very easy for you to understand. Okay, so pay your attention here. This is not a useless article, this is a very useful article. Okay, so this minus, I can write it as root d by 2a whole square. Okay, now this is in a square minus b square form, so I can write it as a minus b, that is, okay, and a plus b root d by 2a. Okay, now if I further simplify it, I can write it as x, and this can be written as b minus root d by 2a, and this another bracket can be written as x plus b plus root d by 2a. Okay, or you can write it as x minus, so why minus here? Because I generally write roots as x minus alpha 1, x minus alpha 2, etc., right? So I am bringing it into this kind of form. So x minus, I'll change the signs, minus b plus root d by 2a, and x minus minus b minus root d by 2a here. Okay, so now these are the zeros of this quadratic polynomial, right? These are the zeros. So what are the zeros? Minus b plus root d by 2a and minus b minus root d by 2a. Because if these are alpha 1, let us say this is alpha 2, so what are these? These are acting as zeros of this quadratic polynomial. And if you analyze these zeros, this is minus b by 2a plus root d by 2a, and this is minus b by 2a minus root d by 2a, right? And these roots or these zeros will be real if d is greater than 0 or equal to 0, right? And these roots will be imaginary or complex roots if d is less than 0, because d is inside this radical sign, and for it to be real, there has to be a non-negative number inside this radical sign, otherwise it will be imaginary or complex, right? So one of the things we can reduce is this, and the second thing is that both these roots, let us say this is alpha 1 and this is alpha 2. So if I want to find the difference between alpha 1 and alpha 2, the difference, or if I denote the difference as like this, what will be the difference? See, there is this added to minus b by 2a, and there is this term subtracted from minus b by 2a. Okay, so if I do the subtraction of these two, minus b by 2a will be cancelled and these two terms will get added. So I will get root d by a as the difference of roots. So this will be my difference of roots. You can do the subtraction part yourself. If you subtract, let us say, this from this, then it will give you root d by 2a plus root d by 2a, that is 2a, and 2 root d, that is root d by a. Another way of subtracting could have been that you subtract this from this, so then you will get root d by 2a minus root d by 2a, that is negative of root d by a. But here we are talking about difference, we are not talking about sign. So I have used this modulus here and written it as root d by a. This is the difference of roots. Whether you subtract the smaller one from larger one or larger one from smaller one, both are known as difference. So sign will not matter when we are talking about difference. So difference of roots can be found directly by writing root d by a, and some other things. The most important thing that I wanted to talk about here using this expression here is the graph of quadratic, right? Let me change the color of this pen. I will use this expression to make some comments about what kind of graph it will be. Okay, so let us make some space here. All right, look at this. So this is the only term in this entire expression that is variable. So we can make changes or we can put various values of x. Rest of the things are constants. Okay. Now if a is positive, let us take two cases. When a is positive. Okay. When this a is positive, what will be the extreme value of this expression? Okay. Let us talk about the minimum value first. F min, minimum value of this expression. Now see, this is positive. You cannot do anything about this term, right? You can only, what you can manipulate is only the values of this x. So at what value of x this expression will have minimum value? Okay, it will have minimum value when this expression becomes 0, right? Because this is a non-negative expression, it will have, right? So this expression here, this is something, right? This is square of something. So the minimum it can have is 0. Minimum value it can have is 0. Okay, and there is something positive multiplied with it. Still the minimum value that it can have is 0. Okay, so for this entire expression to have minimum value, this expression should have its minimum value, that is 0. And when will it become 0? When x is negative b by 2a. It will have its minimum value when x is equal to minus b by 2a. And what will be that value? When x is minus b by 2a, this bracket will become 0. So the value will be a into, this is 0, so I am not considering this. So this expression a into equals a into b square minus 4ac divided by 4a square, that is a, 1a will be cancelled. So b square minus 4ac, b square minus 4ac by 4a, and this is with a negative sign here, right? This is with a negative sign here, so it is minus d by 4a. For this expression I am using d here. Okay, so we have spoken about f min, that is minimum value of this expression. What will be the maximum value of this expression when a is positive? What will be the maximum value? When a is positive, the maximum value of this expression will depend on this x. If I keep increasing this x, the value will keep increasing for this f of x, right? So I can increase x to any amount. Okay, so I can take it to infinity. So that means f max is not defined. It can go up to infinity, that is not defined. So the maximum of this quadratic expression is not defined. That means when a is positive, the maximum is not defined, only the minimum value is defined, and the value will be minus d by 4a, and it will be at x equal to minus b by 2a. Let me create some more space and take the second case. Okay, give me a moment. I think this much space will be enough, because if you have understood case number 1, you can understand the case number 2 very easily. What is case number 2? When a is negative. So if this a is negative in this expression, this entire expression will have its maximum value, when this expression here is 0. Okay, when this expression is 0. Why? Because in this f of x, only manipulation that we can do is with this expression. This expression is going to remain the same. So when a is negative, when this a is negative, we need the minimum value here for it to be maximum, right? Because this expression here has got minimum value as 0. Anything apart from 0 will be positive, like let us say 1, 2, 3, 4. And when this a is negative, and if this value keeps increasing, the effective value of f of x will keep decreasing. Okay, so the maximum it can have is at when this bracket becomes 0. That means it will have f of max will be where x is equal to minus b by 2a. That is, this expression becomes 0. And what will be the value? What will be f of maximum value of f of x? What will be the maximum value? When x is equal to minus b by 2a, again f of max, if you calculate, will become minus d by 4a. So again I have got maximum value of this expression at minus b by 2a, and what is the value? Minus d by 4a, right? And if you have to talk about the minimum value of this expression, when a is negative, f min, it will not be defined or does not exist. Why? Because I have already explained you, when you keep increasing value of x, you can keep increasing it up to infinity, but when you keep increasing the value of this bracket here, effectively the value of f of x is decreasing, because a here is negative. So when a is negative, f of max, you will get the maximum value and minimum value will not exist. So to summarize it, let me clear the board. To summarize it, I can say, in a quadratic expression, f of x ax square plus bx plus c, where a is not equal to 0. So if it is not equal to 0, I can have two cases: a is positive and another case is a is negative. Okay, when a is positive, we have noticed when a is positive, f of x will have its minimum value, and maximum value, that is f max, does not exist in this case, but when I have a less than 0, f of x will have only maximum value and minimum f min will not exist in this case, and when we draw the graph, when a is positive, right, the graph of this quadratic opens upwards, right? That means it has got certain minimum value, but it hasn't got any maximum value. Maximum does not exist. Minimum we know will exist at when x is equal to minus b by 2a, and what will be the minimum value? It will be minus d by 4a, that is reflected on this y-axis. So what will be the coordinates of this point? It will be minus b by 2a comma minus d by 4a. In the similar fashion, you can talk about this graph when the parabola is upside down. This point here will have coordinates minus b by 2a minus d by 4a, right? That is, this case we just have got maximum value, that is minus d by 4a, and minimum value is not defined. So in this case a is certainly negative, and in this case a is certainly positive. Okay, so we will build on this knowledge and discuss about the graphs and signs of a, b and c in the next lecture.